Hello, welcome back to Montana Gear Lab, or my house. The students are on spring break, but I'm still here and I have more questions about joining ropes. One of my favorite things about the sport of canyoning is that there's a lot of innovation in the materials that we use to make gear and then how we use the gear. It's rapidly changing. One of the things that we're seeing more is using slippery ropes, lightweight equipment, and small ropes. But I'm curious how the use of small ropes joined together with larger ropes influences the strength of those joints. Last time, we looked at what happens when you join ropes together at the same diameter that have either the same sheath composition or one of those sheaths is more slippery. This time, we're going to look at ropes that are the same diameter or different. And because in canyoning, some of the time we're in wet environments, we're also going to do testing wet or dry. So let's see what happened.
Today we are going to compare the stacked overhand, Flemish bend, and square fisherman methods of joining ropes. The stacked overhand is tied with one overhand followed by a second overhand. This is a very fast way to join ropes, and it's easily untied after the ropes have been loaded. The Flemish bend is a rewoven figure 8. It's important that the free ends come out of the opposite sides of the 8. The Flemish bend takes maybe a moment longer to tie than the stacked overhand, but it's also fairly easy to untie once it's been loaded. We know that the double fisherman is very strong and secure, but it's horrible to untie after it's been loaded. One modification is the square fisherman. So we have a square knot in the middle, and then we otherwise tie it like a double fisherman. This makes it a lot easier to untie after it's been loaded. So then we got on the load frame and we pulled each of these joined rope samples until they failed. We kept track of that maximum strength. We also kept track of whether there was tail slippage before the end of the test. All right, so what did we find? Well, when trident is tied to trident in dry conditions, we see it takes an awful lot of force to break either the Flemish bend, the square fisherman, or the stacked overhand. We did 3 trials for each of these groups, and we can see that the lowest of these measurements is still about 10 kilonewtons. These are big forces. 1 kilonewton is about 225 pounds. I'd also like to note that there wasn't a lot of slip in any of these conditions. On average, each of these groups only had about an inch of tail slip. The next step was to repeat these tests, but this time tying the 8.5mm trident to the much more skinny 6.5mm polywog. We saw that the stacked overhand and the square fisherman would both cinch up and break at the knot. They wouldn't slip much, but for the Flemish bend, we saw something else. Instead, here we'd load up to 5 or 6 kilonewtons, and then the polywog would just slip through until failure. We can see from the results that it makes a big difference when we tie trident to polywog compared with trident to trident. So when trident is tied to this smaller rope, we see that it takes between 8 and 10 kilonewtons to break a stacked overhand or a square fisherman, which are still pretty large numbers, but only about 5 to 6 kilonewtons to get it to start to slip on the Flemish bend. Again, that's quite different than when trident was tied to trident. Lastly, in canyoneering, it's frequently but not always dry, and then in canyoning, it's almost always pretty wet, so we wanted to subject some of these ropes to wet testing and see what happens. So when the Flemish bend is dry, we see that the polywog will slip through the knot at 5 to 6 kilonewtons. Curiously, when it's wet, something else happens. Instead of slipping at a lower value, instead it actually cinches up and breaks on the polywog side of the knot at a higher value, between about 8 and 10 kilonewtons. Okay, time to look at all the data, so buckle up. On the far left, we have the Flemish bend data. In the center, we have the square fisherman data, and on the right side, you have the stacked overhand. Within those groups, side by side, you have trident tied to polywog versus trident tied to trident, and then all of the red points are the dry tests, and all of the blue points are the wet tests. So things that stand out to me right away. First of all, it is not the case that we lose strength when we join wet ropes, not in these tests. We saw that our strengths were at least as good when we joined the wet ropes. In some cases, like with our Flemish bend on different rope diameters, maybe even a little bit better. Why is that? Hard to say. We didn't design this experiment to get to the answer of that question today. Maybe it's because we cool down these ropes. A lot of heat is generated in the tests. Maybe it's because we have a different amount of surface contact that we're making. Not sure. It would be an interesting follow-up comparison. All right, the other thing that stands out to me is that the stacked overhand and the square fisherman, no matter what we did here, we had high strengths. We could tie them with different diameters. It could be wet, it could be dry. We had at least 8 kilonewtons of strength on those rope joints. So that was exciting because, in the case of the stacked overhand, for example, it's fast to tie and it's fast to untie. So I'm happy to see those data. Of course, there are some pretty important limitations and considerations that you need to keep in mind as you interpret these data. One of which is here we used new ropes. There's no abrasion damage, there's no dirt in the sheets, all those things have the potential to influence how your ropes behave. The next thing is we didn't explore all the different possibilities of ropes that exist. We chose 2 different candidates, the trident and the pollywog. A last important consideration here is that we dressed our knots well, every time. If you don't dress your knots quite so well, you might expect different performance characteristics. Okay, thanks so much for joining us, and check back in later for more data about gear testing.